For 9.6, we're going to look at solving exponential and logarithmic equations. So we do kind of both those things because we're going to use those inverse operations to be able to work through those. Okay, but we do have a couple of definitions. A little bit of it's going to be hopefully a reminder. Let's look here at those definitions. So our first one states for any a greater than 0 and a not equal to 1, a to the x equals a to the y. This is kind of an if and only if. It goes both directions with those. Then x equals y. So they both imply the same thing. We have our bases are the same and our powers must be equal for those. Or if we have two things the same, we can raise them up as powers on those. Okay. And then our second one here for any m greater than 0, n greater than 0, a greater than 0, and a not equal to 1. Log base a of m equals log base a of n if and only if m equals n. Okay, so if we're taking a log with the same base on each side, then m must equal n for that, what we're taking the log of there. And likewise, if we have two things that are equal, we can take the log on both sides for those. So we can use those to our advantage, right? So let's jump into our examples for these, and we're going to be solving on all of those. Okay, number 1 here for this. So if we have 5 to the 4x minus 7 power equals 125. Okay, so here we have two things that we can look at the basis. So the first thing I'm always going to look at is, can I take what doesn't have a power and rewrite it with the same base? Okay, so in this case, because I can rewrite 125 as 5 to the 3rd power, I'm going to do that. Okay, so because now that's created my basis to be the same for those, and so we can use our first rule. Our base is the same, so that means that 4x minus 7 must equal 3. Okay, for those. Well, now we just got to solve for x. So we add our x over, our 7 over, sorry, we get 4x equals 10. We divide by 4 and reduce, and we're going to get 5 over 2 as our answer there. Okay, and we don't have any domain restrictions for exponentials. We're starting with exponent, and we're working through those pieces, okay? Because we can plug any number in there for that x on the exponential, okay? All right, let me find my eraser, sorry. Let's erase here. Okay, the next one, number 2. What if we have 84 to the x equals 70? Now, this time we can't take those and write them to the same base. 84 cannot be written as something to a power, 70 can't either with those. So when this happens, we've got to do things a little bit differently on them, okay? And so that's what we're going to work on here. So what I like to do here for this, when we have these pieces is, I'm going to use the rule where I can take a log on both sides. So I'm going to do log of 84 to the x equals log of 70. Now you'll notice I didn't write a base in there. The reason why I don't put a base in there is because I'm going to use base 10. That way I can use the calculator for those. Okay, and so you are going to do some calculator use here in this to get some decimal approximations at the end, but you're going to have to show your work all the way down to what you're going to plug into the calculator. So be aware of that, okay? All right, well, now we're going to use the rule that says I can take my power and drop it to the front. So I get x times log of 84 equals log of 70. And now I divide both sides by log 84, so x equals log of 70 divided by log of 84. And when we go to put that in your calculator, we're going to make sure that those pieces are in parentheses there for those. So that means x is going to be 0.959. Round appropriately. Sometimes they may have 2 decimal places, sometimes 3 or 4. Read your instructions so that you know where you need to round that to. Okay, so that's how we're going to approach those. Now, we could have done the same thing over here on this one. We could have done log on both sides. We could have moved that whole thing down, rearranged it. We'd eventually still gotten to this same answer. And that's okay with those pieces. So you can work through them either way. All right. Number 3. 3 to the x equals 2 to the x minus 1. All right, so again here, I'm going to have to take a log on both sides for this one because of both of them having exponents. There's no way to write the 3 and 2 to some different power where the bases are going to be the same. So here I'm going to do log of 3 to the x equals log of 2 to the x minus 1. Okay. All right, I'm going to use the same trick as well. I'm going to take this x and drop it down. I'm also going to take this x minus 1 and drop it down in front. So this first side is going to be x times log of 3. This is going to be x minus 1. I want to put that in parentheses, though, times log 2. Okay, we got to be careful there on those pieces. Got to put that in parentheses, or else it's not going to work correctly. Okay. Well, since we have multiple x's, we've got to be able to get them together. So I'm going to distribute that log 2. So I'm taking this log 2 right here. I'm giving it to the x and to the 1. This is x log 3 equals x log 2 minus log 2. 1 times log 2 is just log 2. Okay. All right, so remember that log is just an operator, okay? It's kind of like moving a square around or a square root, those types of things with that. So right now, we're just moving that around as a number. So now we need to get those x's together, okay? So I'm going to move this x over. So we get x log 3 minus, because I'm subtracting that, x log 2 equals negative log 2. Now, since they have an x in common, we can factor that x out. We get log 3 minus log 2 equals negative log 2. Well, to get x completely by itself, we divide there. And so x equals negative log 2 divided by log 3 minus log 2. Okay. Now, when you go to put this in your calculator, you're going to have to be real careful on these. You need to put this 2 in parentheses. You need to put the whole bottom in parentheses, and then also each one of these numbers. Okay. So be careful. If you need some help with that, contact me so that we can get that in there correctly for those pieces. All right. You're going to do that. And I expect to see this down on your paper. Then that's what we're going to type in. And we don't type in before here, because we don't want to create any rounding errors, okay? So we have to be precise. So now we can type this into our calculator and we'll get negative 1.710. Again, I'm just rounding to 3 decimal places for those. And so we have to be careful there on that. So read your instructions. All right, so those are kind of the different exponentials, starting with an exponential, moving to a log in the problems. We don't have domain on problems when we start with an exponential. So let's look at what if we start with a log. So log base 5 of x equals 4. Okay. All right, now we do have some domain problems when we have a logarithm. Okay, So when you're dealing with that log, see if this green marker works. No, it does not. So that's okay. For those, we do need to look at the domain. So here, this piece, since I'm taking a log, if we go back to our definition, this x has to be greater than 0. So when I get to the bottom, my domain is telling me x has to be bigger than 0. So if I get a negative, not going to work. Okay, for those. Now, there's a couple of different ways that we can approach this problem. For this, we can just rewrite it using our log rules, or we can take the power on both sides. So either one's going to work for us with those. So I'm going to just rewrite this using my log rules. My logarithm rules say that I have my base is 5 to the power of 4 equals x. Excuse me, I knew that sneeze was coming. So now we have 5 to the 4th power equals x because we're just doing our rewriting, our conversions that we learned in previous sections. Well, 5 to the 4th is 625 equals x. Well, that's obviously bigger than 0, so that's our answer. Okay, so we can use that. Now, the other option that I was mentioning there, what we could have done if we had log base 5 of x, so I'm going to write option 2 real quick here, equals 4, is we can rewrite this as 5 to the log base 5 of x equals 5 to the 4th power, because of our rule that says that we can do the same base here. Well, log 5 to the log 5 cancels each other out, and that gives me x equals 5 to the 4th, so x still equals 625. So that is another option that you could use in this particular problem here. Right. So got a couple more. 5. Log of x plus log of x minus 9 equals 1. Now here we have to watch for a couple of domain issues on this one. So we've got this first one, we need to look at our domain. We also have this one. So I'm going to go to the side here, domain. For our first one, it says x is greater than 0. So we know that. But here this says x minus 9 is greater than 0, which means x is greater than 9. So really anything less than 9 is not going to work. If we do 8, that's going to give me a negative here, and I can't take the log of a negative. Okay, so that's what it's telling me. All right, well, now we need to start working with our pieces. And in order to do anything, we have to have a single log. Okay, and so we need to put this together using our condensing rules, which says if I have a plus, we can rewrite this as log of x times x minus 9. So we're going to multiply there and get x squared minus 9x equals 1. So x times x times 9 to get x squared minus 9x. Okay? Well, if we remember, since I don't have a base shown, this is base 10. So I can rewrite this now as 10 to the 1 equals x squared minus 9x. Well, 10 to the 1 is just 10. So now we can start solving. I have a square, so that means I have a quadratic. I need to move that 10 over. So x squared minus 9x minus 10. And so 0 equals, here we're going to get what, x plus 1 and x minus 10. And so that means x plus 1 equals 0, or x equals negative 1. X minus 10 equals 0, or x equals 10. But x minus 1 is not in my domain. The x equals negative 1 is less than both of those. This is not in my domain. And so 10 is my answer. So you have to tell me that domain, or you've got to plug it in and check and see that you can't do it for those. So you've got to do one of those two things. I'm going to be looking for it. So I expect you to talk about your domain when you cancel something out for those. So when you have a log, you need to state your domain, whether it's going to the side like I did on number 5, or even just going above here like I did on number 4 to be able to talk about those pieces. Okay. All right, one more. We'll wrap it up here on these logarithms. Number 6, it states if we have log base 2 x plus 20 minus log base 2 of x plus 2 equals log base 2 of x. All right, so again, I'm just going to bust out my domain real quick. This one here says x plus 20 is greater than 0, so x has to be greater than negative 20. X plus 2 has to be greater than 0, so x has to be greater than negative 2, and then x has to be greater than 0. So really that last one is what's going to dictate. It's the biggest one, most restrictive. So anything less than 0 is not going to work. Even though it fills the other two, it doesn't fill this one for those. Okay. All right, well, now we've got logs all the way across, and that's okay, but it still needs to be a single log equals something for those. So we need to put these together using our rules. And so since that's minus, I can rewrite this as log base 2 of x plus 20 divided by x plus 2 equals log 2 of x. All right, well, now because I have a log equals a log, I can just get rid of those and say x plus 20 divided by x plus 2 equals x. And now I just need to solve. I need to get that off the bottom and work through it, okay? So I'm going to move that over. So x plus 20 equals, and I'm multiplying, so x squared plus 2x. Since I have an x squared, that means I need to move everything over. So 0 equals x squared. I'm subtracting 1 from the 2 to get an x. I'm subtracting the 20. So that means that I'm going to get x plus 5 and x minus 4 from my factored form. And you will be able to factor these when you're doing it, okay? And so x plus 5 equals 0, or x equals negative 5. X minus 4 equals 0, so x equals 4. But it can't be anything less than 0, so the plus 5 is gone, and x equals 4 is our result because of our domain, okay? And so those are the different styles of problems that we're going to see here. You've got to pay attention to. Did they start with an exponential? If they did, my domain is all real numbers. So whatever answer I get should be good. But if I start with logarithms, then I need to check the domain for those. And I'm looking for that piece in your exam. So I expect to see you checking that domain when you're doing those, just like I did on those problems. And it can be as simple as writing it above each piece and going, okay, here's my domains, so that I know to look for my answers in there, okay? So make sure you're getting in early to look at those problems.